Hi guys, back once again. Wow. Yep. What we're looking at here, a common question that comes up inside the GCSE Physics or the Combined Science paper, is why does a rod move when you flick the switch? Okay. What am I talking about? Well, here I have a copper rod. This is not magnetic. Falls off of my horseshoe magnet. I have a strong uniform magnetic field in this horseshoe magnet. It's my daughter's hair clip stuck to the magnetic field. Both poles. Doesn't matter which pole. This is a magnetic material, and magnetic materials are not repelled. Magnetic materials can only be attracted, unlike magnets. So there we go. Attracted to the north, attracted to the south. Okay, strong magnetic field. Well, what we're investigating today is the motor effect, and this is why a rod will move. When I pass current through this rod, we will get concentric circles, a magnetic field spinning around this rod. Now, that's a temporary magnetic field, and it relies on the current for that temporary magnetic field to be created around the rod. If I switch the current off, that temporary magnetic field will disappear, and this will just go back to being a boring copper rod. So we're going to pass current through that, and we're going to see what happens if we place the temporary magnetic field inside a permanent magnetic field. So here we go. I have copper rod, no magnetic field around it, but I definitely have a permanent magnetic field here. Look, permanent magnetic field. So we're going to have two magnetic fields crossing each other at right angles when I flip the switch. Let's see what happens. Nothing. Oh my good gosh, why you fail me now? Let's tighten. Oh my good gosh, even worse, why you fail me, why? Okay. The failure will not be tolerated. Oh, bloody hell, it will be tolerated. I think my batteries are on the blink. Running out of juice. Of course, if the current decreases because my batteries are cheap-ass Amazon Basics, then I'm not going to get a very strong temporary magnetic field. But let's have a look. Wow! Hopefully you saw that. The copper rod moved, and it moved out of the horseshoe. Let's open the switch. If I open the switch, there's no current flowing through it. I have a permanent magnetic field, but no temporary magnetic field. Let's do that again. Yay! Okay, so the copper rod moves. Why does it move? Well, it's called the motor effect. And any questions on the motor effect that you get, basically, why does something move when the switch is pressed? Why does a motor spin? Why does the rod move? You've got to state the motor effect. And the motor effect is really three main things. Current in a rod or current in a wire creates a temporary magnetic field. This interacts with a permanent magnetic field, resulting in a force on the wire or the rod. And that's why our wire or rod will move. And that's your answer. Now, you can often be asked a follow-up question, which is, how can I make this rod move in the opposite direction? So once again, our rod is moving out of the magnet like that. How can I make it move in the opposite direction? There's two things I can change about this circuit, which will make this rod move in an opposite direction. So we'll make it come into the magnet. The first thing I can do is reverse the polarity of the magnet. Change the poles or the direction of the magnetic field. And what we should see when I do that is when I close it now, it should move in. And there we go. We've reversed the direction of the rod by reversing the magnetic field. Okay. Let's try reversing the electrical connections or reversing the polarity of the battery. Or you can say reverse electrical connections. So I'm turning my battery around. So plus is at this wire and minus is on this wire. what's this going to do to the direction of the rod? Well, we just saw the rod move in, so now I'm hoping the rod's going to move out again. Hey, and there we go. We've reversed the connections. Super duper duper. You may be asked, how can I make the rod fly out faster or move further? You guessed it, I can add a cell or more voltage or more current. So any of those answers would be good. Or use a stronger permanent magnet. Move the poles of the magnet closer together. These are all ways that we will exert a greater force on the metal rod. All right, guys. I'm here to help you get to the marks in your exams and really smash those GCSEs apart. So if you like, please subscribe, please like the video and check out all the other videos. Lots of the videos go into detail about magnets, electromagnets, the motor effect, the generator effect, induction, solenoids, all the kind of lovely terms that get you excited. All right, guys, take care. And remember, let's get to the marks.